ratio at omega c naught exactly equals to 1. That's how we find Ku. So, instead of iterating, I know Gu, right? The only thing unknown is Kc. As a matter of fact, I know something about Kc. What do I know about Kc? The sign. Thank you, Jack. Exactly. But we know sign of Kc. Remember, for Ziegler-Nichols tuning, you have open loop stability. So if I'm open loop stable, having a GU, how do I find sign of Kc? Sign of GU 0, exactly. With me? So far so good? I hope this long review has been helpful in putting everything in place. So, how can I write from my GOL, which is GU Kc, how can I write it so that I have a positive real constant as the unknown? I have to rewrite Kc as its absolute value. And since, so I can write that as GOL prime times absolute value of Kc. And what is GOL prime? Until now I was using GU prime as symbol, but to make it more clear, I'm putting now a GOL prime as symbol here, okay? Previous symbol, GU prime. But if Kc is positive, then positive number equals absolute value, so GOL prime equals G. So, where but if Kc is negative, what should be GOL prime equal to? A negative GU. Exactly. Previously, I used the symbol clear? So, how do I find Ku and Pu? By using that, okay, how we find Ku and Pu without iterations? I've taught this material probably at least once a year, so probably about 30 times. And it isn't after 30 times I still find new ways of changing something. This is the very first time I teach this material in this way. So it's not going to be, it's not like that in the notes. Okay? But I think it hopefully makes it more understandable. So, no?
We'll see.
Okay, let's continue. So previously I used GU prime for GOL prime. Okay, so what can we do then? So instead of iterations with body plots of GOL equals GU. GUKC. Do a single we just put a single bond of GOL prime. Since absolute value Kc is a positive constant, is a B, so since it's a positive real constant, that means that phi of GOL prime is equal to phi of GOL no matter what magnitude of Kc is. And therefore, omega C naught of GOL equals omega C naught of GOL.
You forgot the C on the KC at the top.
What did I forget?
To the right. All the way to the right. UKCC.
Oh, yes. Thank you. Clear? So we can find immediate omega C naught without iteration. And then what is Ku? Ku is Kc for which magnitude of GOL at I omega C naught is equal to 1. So in other words, magnitude of GOL prime at I omega C naught times absolute value of Kc equals 1. So, as I put here, P is my absolute value of Kc. It's going to be the arbitrary at omega C naught, which is what? 1, right? Well, this is magnitude of GOL prime, arbitrary is magnitude of GOL prime at I omega C naught over magnitude of GOL. Magnitude of GOL at I omega C naught over magnitude of GOL prime at I omega C. So that means that I immediately get magnitude of Ku. Oh, sorry. Okay, magnitude of Ku equals 1 over magnitude of GU prime at I omega C. And no iterations were needed. That was the trick to avoid iterations with the Ziegler-Nichols method. But another family of problems is, remember we have the heuristic have a gain margin minimum of 1.7. So I may want to ask you to design, modify a KC or design a KC that gives you a specific gain margin. Here is a problem that is from an old example. So example 2. So clear? This is just review. So now I'm doing an example that you haven't seen before. Actually, let's say example. Question? So this was example 1, Ziegler-Nichols tuning application. Okay? Josh, question?
No.
Thomas, question?
What was the equation you added on that one? Covered that. You added something over there for P.
Oh, yeah, I also remember the amplitude not determined GOL at I omega C.
Oh.
I just
I
replaced
didn't
like
get to
that.
see it.
Since I didn't write here, since I wrote here instead of amplitude ratio, I wrote this. This is the amplitude ratio. At omega C. Right? All right, example 2. Without iterations, okay, let's say, okay, let me give you an example. GQ equals, let's say, minus 10 over 3s plus 1 e to the minus 7s. And a well-known controller tuning method that is absolutely lousy for disturbance rejection, but is fine for set point following. And they never say that it's lousy for disturbance rejection. So I wrote one page little thing and sent it to them and said, oh, this is well known. Okay.
You lied?
It's called the IMC method. I don't know if I have time for a joke.
Yes, you do.
Yes, you do.
IMC stands for internal model control. Internal model control. But the inventor of internal model control was a professor at Case Western, close to Cleveland, by the name of Cole Brosilau, and he named it inferential control. That was a bad name, because inferential control is a name that exists and means something different. Inferential control means that, for example, you want to have a set point on composition, but you don't have a non-line measurement of composition. You have a non-line measurement of temperature. And you have the online measurement of temperature, and you have a model that allows you to infer composition from temperature. And you use the model in combination with the temperature measurement for the control. So that's what's normally called inferential control. But he called it for something different, inferential. Martin Morari at Caltech picked it up and developed it further, and he called it internal model control. And for many years, it was kind of amusing in conferences. Brosilau's group would present it as inferential control. Morari's group would present it as internal model control. And it was kind of hilarious because they would refuse to use the same name. So Tom Edgar of Texas Austin proposed a grand unification. And here was Tom Edgar's grand unification. Remember, one name is inferential. The other name is internal. So the unification name, take the first 4 letters of inferential and the last 4 letters of internal.
Infernal. Good.
So, all right, let's move on. So, one of the, for first order plus time delay, infernal control sets tau I so what will be tau I then? 3, right? Which means that GC is going to be Kc times 1 plus 1 over 3s. So, here's the problem. Without iterations, with a single find the value of Kc, that gives us a specific gain margin that gives Gm, let's say it was 1.9. So, given the principle of what we have just learned, the only thing unknown is the magnitude of Kc, right? We can use exactly the principle that we discussed. So without any iterations, in the single body plot, we can find the appropriate value of Kc to give us the desired gain margin.
You said 1.9?
Yeah. I'll just give a number. Heuristic is greater than 1.7, right? So 1.9 might be a reasonable number to use. Clear, everyone? So, how could I do it? I could do it by iterating. Iterating is guess values of Kc, right? But what is the total GOL? The total GOL is going to be GU times GC, which is minus 10 over 3s plus 1 e to the minus 7s times Kc times 1 plus 1 over 3s, right? If we're smart, we're going to do a cancellation. I can rewrite that as minus 10 Kc over 3s plus 1 times 3s. Making common denominator, you have 3s plus 1 e to the minus 7s. This cancels, and I have minus 10 Kc over 3s e to the minus 7s. If I can factor a positive number out and have my unknown as a positive number factored out, then I can do exactly what I was talking about. So, what is Kc? I want to rewrite that as absolute value of Kc. But what sign of Kc? Its sign is
Negative.
the system open loop stable.
Is it negative?
Remember, that S that you see here is from the integral action. It's not part of GU.
Is it
GOL
negative?
can have one denominator with that 0, which is what it has. We are okay.
Is it negative?
So,
Oh wait.
sign of what? Sign of Kc, okay. I will take you.
But I thought you plug in like 0 for S's, but then
Yes?
there's a 0 at the bottom, so
But what do you plug?
negative infinity.
GU
Oh.
of 0. What is GU of 0? That's the GU. Remember, GU is this part.
So negative, yeah.
So, sine of minus 10. With me? So, GU of 0, GU is this part, is without the controller transfer function. So, if you put s equals 0, what do you get? Minus 10 into the 0 over 1. Minus 10. So, what's that? Negative. Therefore, Kc can be rewritten as minus absolute value of Kc. Because remember, everything holds factoring out a positive real. Because a negative real doesn't have phi 0, it has phi minus 180. So I cannot factor out any real. So GOL is equal minus 10 times minus absolute value of Kc over 3s e to the minus 7s. In other words, 10 absolute value of Kc over 3s e to the minus 7s. Okay? So I can rewrite it as GOL prime times absolute value of Kc, where GOL prime is 10 over 3s e to the minus 7. Christian, how are you doing? Okay. So, what I have to do is,